All right, it's time to look at the topic 11 worksheets, starting with 11.1 about three-dimensional figures and cross-sections. I think this one's not too bad of a worksheet in the grand scheme of things. Number 10, if you rotate rectangle ABCD around CD, what is the volume of the resulting three-dimensional figure? Well, the figure that we're going to get is a cylinder. It's going to be round there. And the volume of a cylinder is found by doing the area of the base, pi times the radius, which in this case will be 12, squared, times the height of the shape, which is 5. And if we go ahead and put that answer in terms of pi, we will get 144 times 5, which is 720 pi. And since this is a volume measurement, that will be centimeters cubed. Number 11. Philip was asked to find the number of vertices of a polyhedra with 32 faces and 60 edges, but he used the formula wrong. He should have said F plus V equals E plus 2. Faces plus vertices equals edges plus 2. So that would mean 32 plus the number of vertices equals 60 edges plus 2. So 32 plus something equals 62. That means the vertices are 30 vertices there. Number 12, a tetrahedron is a polyhedron with 4 triangular faces. Can a plane intersect the tetrahedron to form a cross-section with 4 sides? Yes, it can. The shape has 1, 2, 3, 4, 5, 6 edges, and therefore it can hit at least 4 of the sides. So if I made a point here at the midpoint of 4 of the sides, just like this, and I connected them together and made sort of a rectangular face in the middle, maybe it's exactly rectangular, maybe it's a little off, but either way, that is a plane that I could make, a cross-section that I could cut through that shape. Number 13, can the intersection of a plane and a triangular prism produce a rectangular cross-section? Yes, it can. If I go through the same height at the beginning and the end here, I'm going to create a parallel rectangle to the one at the base. And that is going to be just a smaller, thinner rectangle, but it'll still be a rectangle, just like that. So yes. Number 15, does the figure have a cross-section with 5 sides? Draw the cross-section or explain why not. There are cross-sections with 5 sides in here. I can draw one to kind of explain or show you. If I put a dot on each of those sides, dot on this side, and maybe this side or this side. You can basically put a dot on whatever side you want and create the shape that you're looking for. And maybe I'll put one right here. And if I put all of those together, then I come up with sort of a pentagon-shaped cross-section there. And if you put a rectangle through there, a cross-section, if you fruit ninja'd that, that would be a 5-sided cross-section of the shape. B says, what is the maximum number of sides that a cross-section of this figure can have? It can have 5. I believe the rule is that a figure can have the same sides in the cross-section as the number of faces of the shape, which is why this tetrahedron could have a 4-sided cross-section, and this shape can have a 5-sided cross-section. Number 19, a polyhedron has 16 edges and 10 vertices. So we use faces plus 10 vertices equals 16 edges plus 2. And that gives us faces needs to be 8, because F plus 10 equals 18. Number 20, draw the cross-section formed by the intersection of plane A and the polyhedron shown. What type of polygon is the cross-section? Well, if we have that cross-section going right there, we're going to get this long, skinny hexagon. Kind of like this. Just like that. So that is a hexagon. Number 24, if we're going the other way, we're rotating this pentagon around the line shown, we're going to get a cylinder at the bottom, and it's going to have a cone on the top, kind of like a silo. It is a cylinder with a cone on top. After that, we're going to rotate this circle about a diameter, which is, of course, going to give us a sphere. 26. Parker cuts 12 pentagons and 20 hexagons out of fabric to make the pillow shown. The pillow has 60 vertices. If it takes 20 inches of thread per seam to connect the edges of the polygons, how many inches of thread does Parker need to make the pillow? So we're going to use the formula here. And we have, let's see, 12 pentagons and 20 hexagons. Those are all faces of the shape. So altogether we have 32 faces. So we're going to use 32 faces plus 60 vertices equals the number of edges plus 2. And we'll find that's 92 equals E plus 2. So 90 is the number of edges of the shape. And then each edge takes 20 inches of thread per seam. So we'll do 90 times 20. We'll need 1,800 inches of thread to get through there. Number 27. A gem cutter cuts a polyhedral crystal from a garnet stone. The crystal has 10 fewer vertices than edges and twice as many edges as faces. How many faces, vertices, and edges does the crystal have? So, of course, we know that the formula is faces plus vertices equals edges plus 2, which means then we can change these things. To me, it looks like, let's see, the number of edges is based on the number of vertices. No, sorry. The number of edges is based on the number of faces, and the number of vertices is based on the number of edges. So faces is the original, so that will be our x. Plus, and it says twice as many edges as faces. So the edge number is 2 times the number of faces. Whoops, I guess I will use x for that amount as well. And the vertices are 10 fewer than the edges. So if the edges are 2x, the vertices are 2x minus 10. And of course, we have the plus 2 from the formula. So we simplify 3x minus 10 equals 2x plus 2 and just solve. Find out that x equals 12. That means our faces, which is what we represented with x, is 12. The vertices, which is 2x minus 10, 2 times 12 is 24 minus 10 is 14. And the edges is 2 times the number of faces, so 12 times 2 is 24. Next, complete the table for each polyhedron. Of course, we're just plugging these into the equation. So there should be 20 vertices, 15 edges, 6 vertices, and 6 faces. And then finally, this cross section is, of course, a pentagon. So nothing too crazy on this worksheet. Let me know if you've got any questions for me, but I think you will get this figured out.